Hello everyone, and welcome to another episode of Ethan's Maths. And today we're going to go over differentiation. What was that? No, not acclimatization, silly. Differentiation. No, not artificial insemination, you donut. Here, differentiation. Alright, so basically what we do with this is we use it to find the gradient of a function at any point on the graph. And in the exam, you might be, well, Ethan, what does the equation look like? Well, what does it look like? Well, I've made one here just for you. So say a is a number and n is something to the power of the number, right? So you got ax to the power of n, and if I wanted to find the derivative of that, I just times a by the power and take one away from that power. Easy, we got it. Okay, so what if you got 6 over x squared plus 2x? Well, the first thing you'd do is change the 6 over x squared into 6x to the power minus 2. And that makes it a lot easier for you, because then you can do some funky maths on it. Dy over dx equals minus 12 to the power of minus 3 plus 2. And that's that. Because you do 1 over here, it's just 2 over here, yeah? 1 times 2 is 2. 1 minus 1 is 0. So the x disappears, so it's just 2. So you can also get questions where you need to use it to find the equation of a tangent. So here's a question. Find the equation of the tangent to the curve y equals x squared minus 2x minus 3 when x equals minus 1. So the first thing we're going to do is do that funky math thing. Dy over dx equals 2x to minus 2. When x equals minus 1, dy over dx equals minus 4. And then you use that to find y. So just, chuck in x again, and then get y. Easy peasy, right, guys? Easy peasy. And then you've got the equation for a line here. Y minus y1 equals m, x minus x1. You should all know this by now, guys. Come on. So the equation is y minus 0 equals minus 4, x plus 1, if we sub it all in. So y equals minus 4x minus 4 at minus 1, 0. And that's all you need to do. Wait, there's more. Stationary points. And if we wanted to find stationary points on a graph, we'd have to use the second derivative, which looks like this instead. Instead of dy over dx, it's d squared y over dx squared. And if it's greater than 0, it's the minimum point. If it's less than 0, it's the maximum. And if it equals 0, it could be a point of inflection. So, okay, exam time. You go in the exam, you sit down, boom. Find and classify stationary points of y equals 2x cubed, minus 9x squared, minus 24x, plus 45. And you're in the exam and you just cry. You just break down crying. You don't know what to do. But then you remember, Ethan did a video on it. Ethan did a video. So basically, yeah, easy peasy. Just put it in, chuck it in again, do that thing from up here. You remember that? Yeah? So go back down. You got that, very nice. That divides by 6 to get x squared minus 3x minus 4. Then we can factorize it and get x. And then we can put x back into the equation to find y. And so we get 2 stationary points here. We get 2 points. So, and now we need to classify the stationary points. So we just sub 4 back in again. Or in this case, it's 4 and minus 67. And we get 30. 30 is greater than 0. So it's minimum point. And then we do it again for the other coordinate. And it's less than 0. So it's a maximum point. And if you put a value of x in the second derivative and it equals 0, and that means it doesn't work, right? You need to try something else. So what you do is you'd find the derivative slightly to the left and right of the value that you have, and it could be a point of inflection, maybe. If it decreases and decreases again, but if it decreases and increases, it's a minimum point because the line's going down and then up. Thank you very much for joining me today. Have a lovely day, and yeah, rock on.